So my name is Matt Nanney. I am the Enterprise GIS and Remote Sensing Manager at AECOM local. AECOM's a big company. I'm the regional area manager there for that. I want to start off with a couple conversation topics and talking about data. So thinking about data, conceptualizing data, why are we collecting the data, and just looking at it at a broader scope as we go into this conversation. We're going to talk about UAS-based lessons learned and applications of GIS. So I'm going to focus less on the technical data processing portion of UAS and more on the overall picture of what that deliverable would look like as a whole. So this is an overview of the group as you can see of it. I've seen a wonderful change in the industry in the last few years for remote sensing in general. Before we were the UAS group and you're the UAS manager. Now you're the remote sensing manager. We do a wider suite of things as part of that. These are some of the verticals thereof. The two that are probably near and dear to my heart are the EMAP or Enterprise GIS programs. And what we've really tried to do over the last few years is integrate everything together with satellite-based LiDAR photogrammetry, UAS derived data and other sorts into a comprehensive deliverable as part of that. So this is probably one of the slides I can spend the rest of the day on just dissecting, but I'll give it a quick overview here. Just talking about the different components of the team that's required for UAS operations or remote sensing operations as part of that. Certainly the surveyor, well-known role within that to be able to set ground control, verify, validate data as part of that. And then also the pilot. The pilot being a very separate skill set, specialized skill set within this whole branch of what it is to perform a UAS operation. And I'll get into a little bit on how we've approached that here over the years, but really it's more than just have a person who, I flew a drone for an hour, I'm a pilot, valid, you have your FAA 107, that's very true. However, the skill sets and the safety management programs that go into building a productive pilot who is skilled to be able to execute and then grow. So you might start off with a small UAS, like that blue one over there. You might grow to the larger UAS that's over there. And yes, that is 100% there for my demonstration purposes at this moment to poke at as part of that. So really just fostering all skills and growth, and then really looking at it from a team perspective, how do we get people to, one, get to a certain stage, certain level of competency, and then grow that competency over time. The next would be the data processing portion thereof. So photogrammetry, LiDAR data processing, converting that information to CAD through the analysis portion of that exercise. So I like to think of it like this. You may be one of wearing many hats on a given project. It's very common to have 4 different people, 4 different entities or groups working on each of these different verticals, but you may wear 2, 3, maybe even 4 of the hats given the project needs and the desired deliverables as part of that. So going into a little bit overview of the program, one thing that we find is a challenge is, once again, having 40 plus pilots, 50 plus pilots now, and then also trying to keep everyone current, manage those systems. Before we were with Skyward system, now we're with Aloft as part of that. And just trying to manage both the fleet aspect, the insurance aspect, everything that's associated with that, and then still figure out a way to grow those skills within pilots. One thing I always like to say is that we take people who are specialists, bridge inspectors, environmental scientists, folks like that, and then we try to cross-train them to be UAS operators and also help grow those data processing skill sets over time. Here's a brief overview of a few different verticals that we found some success with, that hybridization of UAS first into a GIS system as part of that. Certainly site audits and things of that nature, leveraging field maps, data collection. I being a GIS person, I start off every application by building a field maps application so I can at least track where I am, track where I've covered, look at areas, where was that gate? Hey, what was that gate code key? Putting all of that into a system, that way I have easy access to that. Also, just something as simple as like, well, we're here and we need to get to the next site. All right, let me use field maps to navigate over through there through a third-party navigation app. Certainly, one of the larger applications we've seen is areas that we consider hazardous conditions, and or especially during COVID, areas that were inaccessible. You can fly a drone from outside the gate of the construction site. of the facility, and not have to get involved in one, safety management programs that might be at the facility thereof, but it's seen as a safe way to broach that. And certainly web application integration as part of all of that, getting those final derived products, getting them into a visualized format to be able to give back to the client and say, you asked for drones because you knew drones kind of did what you needed to do, but here's what we're trying to do as a whole. Get to the web application integration. Here's all your data. Interact with the data. Make decisions based off of that data. Here's an overview of UAS kind of operations and just the broad scale of platforms for this. So we see some of the integration we see at the upper left-hand corner of Skydio X2. We see an EB, we see the census unit that's here today as part of that. And really, where do they find that overlapping Venn diagram of capabilities? Certainly starting off on the lower end with the quads, sometimes you need to deploy a quad. I think one misconception early on too was that, oh, we're going to get a drone program. We're going to buy the drone does everything. And then maybe we scale up to something with a larger payload capacity. The reality is different drones for different purposes are required and often requires a lot of financial investment to be able to cover all the verticals needed for that. Recent case in point, and I'll give in some project examples of this, is what we've done for part of our work with a federal client. They required a very specific drone that was identical to the drone we already had for the Skydio X2E Echo. They required the Skydio X2D Delta to be able to fly and meet those spectrum signature requirements for that. Therefore, we had to buy another identical drone, and we're looking at both side by side. They're the same serial numbers, there's just different software, maybe a slight hardware component as well. These are a few of the different verticals. We've done quite a bit with thermal imaging over time, certainly with photogrammetry and LiDAR as well. But this is where we've seen some successes thereof, especially for looking for water infiltration and just really well seeps, things of that nature. We've done some interesting mapping projects thereof, just looking at different remediation sites, contaminated sites for that. I come from an environmental background, so it tends to be heavily skewed environmental where we give these project examples. Certainly going into the photogrammetry and LiDAR, looking at different levels and needs and really identifying from the get-go, what's the desired deliverable? What's the accuracy? What are the accuracy requirements? What's the spatial resolution? What's the temporal resolution that's needed? Do we want to go back out there several times over? And we go, ooh, we better set ground control for that. We have something to tie it to because we're going to get several different data sets floating on top of one another as part of that. And it really goes into the larger UAS data management plan. And then getting into further analysis. Certainly there's aspects of change detection, something done there for that, automating and asset detection. Planimetrics is kind of part of that as well, but AI and machine learning capabilities. There's a newer technology out called NERF right now. I will probably butcher it if I try to remember what the acronym stands for: neural reflectance differential, something like that. The idea is that rather than using 2D objects that you see in photogrammetry and driving 2D data, it will compile that into a 3D area. So it'll take 2D information, compile in 3D to create a 3D model as part of that. Certainly leveraging AI and machine learning capabilities thereof. NVIDIA has a good tool set for that I've played around with a bit, and it does quite a good job. All right, talking more about the GIS workflow and where does UAS fit into that workflow. What you see here is a diagram of what we call like the enterprise GIS or EMAP system for that database integration, but where does the UAS fit into this portion? A couple places. One, derived field maps that we're going out with from, say, we fly one day, process the data, go out the next day or so forth, being able to have that baseline map and add that into the field maps application. That's been a huge key advantage thereof. Or pulling those elevation products as they're going out making decisions like, well, where do we drill next? Let's go for that. Let's have that elevation data readily available to know where those sorts of things that they're trying to detect flow or groundwater sampling thereof. So pros and cons of cloud-based photogrammetry. I'll start off by saying I absolutely love Drone Deploy. It does a lot of really cool stuff. There are limitations. Mostly I like it for cloud-hosted title services. If I have a project and I'm going to process it in like Pix40 and Metashape, what have you, I'm still going to probably throw in a Drone Deploy just to have that as reference. We can share that. We can share that as that project with the client through other licensing agreements, and just giving transparent access to the data, regardless of the accuracy requirements thereof. Certainly, when we get to data bottlenecks, something from a recent project and something we've experienced on prior projects, we're going to rush, and collect a whole bunch of information. And the idea is we're going to try to turn that information around as quickly as possible in the form of a sub-meter accurate orthomosaic for that. You really have to use cloud-based processing to be able to do that. If you try to get that through the desktop process, even automated through scripting, it's still going to take quite a bit of time for that. So mobile data collection and drone photogrammetry, a couple applications. You see some 2D, 3D modeling, change detection that can take place for that. Another popular application, and one we're starting to see grow a little bit, especially when it comes to a 3D scene, and I've got another slide on that later, is people becoming more interested in 3D modeling. Before it was kind of a lark. You say, oh, wouldn't it be cool if we did this? And you hand them an OBJ file or FBX, and they go, what do I do with this? You're like, well, you can go download this player and then you can play it in here and you look at it and spin it around and make decisions based on it. But trying to bring that into a more interactive environment as part of that and leveraging GIS in order to do so as a 3D scene. I'm going to go into a few project examples here for some recent projects that we've done for City of Raleigh. To date, we had been supporting a larger dam inspections and SWIP inspections program that they had going on with the city, or excuse me, BMP inspections. So one of the things they wanted to look at is a few different key areas to say, hey, what's going on here, especially as it comes down to vegetation management. Think of it less as like the need for multispectral vegetation health management, but really just to saying like the city may own the asset, the city may not be in charge, may not own the asset and be in charge of the maintenance thereof. Using drones just to document what was out there. So we have the dam inspection program, we have all of that information from there, but then also just flying it annually, biannually, to be able to say, well, this is the vegetation, or is it growing, is it shrinking? Okay, it's growing. Clearly, we need to do something about that. Maybe they need to send another letter out as part of that. It's good to know here, IR thermal imaging as well for dam inspections and for cracks, leaks, things of that nature. We certainly had a few applications. I would call them successful. I would not call them just jaw-dropping results that led to an incredible feats of understanding. It's more that, okay, we were hoping that the water wasn't infiltrating here. Okay, it is. Okay, we already knew that. All right, well, let's go over here. Is it infiltrating here? No, it doesn't look to be infiltrating here. Okay, good. Now I have peace of mind that things are going according to plan. This is another stream restoration project we did in Wake County. As part of that, as part of their annual assessment. And the idea is there was a huge regrading effort that went at the same time as doing a stream restoration project. So you see example on the left there of the overlay of the contours, and on the right-hand side what the control looks like for that area. There's about 100 feet of relief between the top of the hill to the very north side there by GCP 14 for that, down to the bottom where the river was. The primary deliverable, the most meaningful deliverable from this came from the accurate contour information we were able to generate through that rasterized data set. So this was another recent project. It's pretty cool. It was an area in a mountainous region. I'm leaving out project descriptions and clients here on this one purposely. So we had about a 1.5 mile stretch of scenic highway with high landslide activity. So as part of what we needed for the geologist to be able to do the redesign and said, well, hey, can we go out and create a 3D model or a 2D orthomosaic of the vertical surface of the rock wall following along this road? Great lessons learned on this one. The answer was yes, if we had more availability of space. So early on, because the land on either side is owned by a National Park Service, they said, oh, you can only fly on the road. Now, having seen the site in detail, we go, sure, we'll go out there and we'll try. It was during the winter time as well, which is another variable for that. We flew a Skydio X2D thinking, all right, we'll just take it low and slow, going up and down, taking images, successive overlap, manual exposures for that, and then we'll do an autonomous flight to try to get the bulk of that information. That was largely successful for 2D, but not as much for 3D. Unless you're on a perfectly open area here, as we're seeing on the left-hand side, where you can see some of those contours and differences there from that data. One of the things we're looking at too is working with the client on them going out and acquiring more data during a better season to be able to acquire that data, and then also trying to get a variance from the National Park Service to be able to essentially fly and be able to capture enough information for a 3D model, or for that 2D orthomosaic that's vertical. Big takeaway from that too was this is a great project for terrestrial LiDAR. We were kind of gearing towards that. Client didn't want to pay for it. So they, well, we want to try the drones first. Okay, let's try the drones first. And now we're at a stage where, well, let's try the drones again and see, and we'll fly it. And can you process the data? We're like, yeah, we can process the data. But ultimately, this was probably one for a terrestrial LiDAR project. Here's a couple other scenes. You can see the sparse point cloud and some of the other derived products. Here's another project example from a federal client that we have. So this, once again, I talked about the Skydio X2D and the need for DON approval as part of that. So in a nutshell, the whole Blue UAS initiative, that DoD certification that's required for that, and they're on that wonderful list, does not mean the individual branches necessarily recognize or have validated that data. It just means it's a great candidate for them to do further evaluation. What we further found out is only certain vendors or certain manufacturers went through that process ahead of time. So for one, we're going through that with a quad now that it's going to take 6 months. We started that process back in December to be able to get that approved, to be able to fly, in this case, on cantonment within the confines of that federal property for that. Spectrum waivers were required, other waivers, exhaustive exhaustive kinds of approvals, way more than a normal operation. Case in point, we had to get not just airspace authority from the FAA, approval from Flight Airspace Authority locally for that, which was not an issue. General approval for the base commander to be able to fly. And then in addition to that, there's something called a range safety officer. Because the entire installation is considered a range, we had to have a range safety officer. They're calling in, be at the beginning of the flight, every 30 minutes during the flights, and when we left a different area to go set up. And then when we got to the new area, call in before each flight. And took a lot of orchestration. Where we found success schedule-wise is to try to plan 2-day stints. Go out there for 1 day, 2 days, and that way we're not exhausting air control or Blackburn in this case, to be able to overstay our welcome where they still want to work with us as part of that to get those derived products. Certainly what that created was 2 days of data acquisition, allowed for 2 days of data processing, and we were able to very quickly turn around data as part of that. I'll go briefly as part of what we're doing there today for the construction site and environmental permitting aspect of it. In this case, we were looking at a variety of different MILCON sites, construction sites, dual capturing with the X2D with both RGB and thermal imagery. I'm going to call a bright shining light attention to this. On the left-hand side, cool oblique model of the 3D surface, looks nice, looks aesthetically pleasing, awesome for a presentation. What's the value there? On the right-hand side, look at that cool thermal image. Oh man, you can see stuff and like, this looks cold. Okay, that makes sense. It's water, it's cooler because it's the morning when I flew this. The other areas look warmer. Okay, there's metal, that makes sense. And what's the value of that information? And the answer is we're working on that. We're creating a baseline of data there and hoping to, even though we don't have a direct applicability, especially with the thermal data, is that we're going to collect that, process it over time and see where that value changes there for it. In this case, that data is non-radiometric as part of that. So i.e. it's not tied to a real world Fahrenheit temperature thereof. It's an overview of some of the projects that we did in that area. You see the different MILCON sites that are scattered throughout the installation and see a picture of what some of those derived products. So they range in size from 5 acres to 50 to 100 acres for that. Skydio X2D actually did quite a good job considering its limitations photogrammetrically. All right, I'm going to talk about LiDAR briefly, but I think the other speakers here today will probably talk about that more in detail, so I'll skip over that and talk about one thing we had from a recent project. So 400-acre site in South Carolina, client very much concerned about confidentiality, wasn't really willing to share the same level of detail about a site as we normally would. Well, after finding it, getting approval, we essentially had to pre-agree that we could do the project. Got out there, it is 400 acres of forested area. Can't maintain line of sight with that. Therefore, we got a scissor lift to be able to accommodate that. Scissor lift broke once or twice during the part of that process where the pilot was up, essentially stranded for about half an hour. Ultimately came down that the scissor lift wasn't leveled correctly. So it added a little bit more time for that, but were able to acquire and process 400 acres of that LiDAR imagery. If you see a good example here, what does that RGB imagery look like? And then what does the LiDAR imagery look like to be able to make those design surface decisions for this larger construction area? We talk briefly about large scale environmental assessments here, but show this PowerPoint. This is something we've been working on for a few years with a similar client, just looking at different levels of parcels. And really what that allowed us to do is to evolve towards fixed wings. We started off with an EB, did great, collected great data. We were able to see that it was not intrusive to wildlife, things of that nature. And we quickly realized that, man, we would be really cool if we could just go beyond visual line of sight and be able to see where you are. Hence, we made some investments here with the census unit today as part of that. And really what we're looking for, and this is just a demonstration model here of the surface that was created. In this case, it was with the EB. We're looking for encroachments, homesteading, things of that nature, and then ultimately going back to the same products for change detection. Well, what changed from year over year as part of that, and making those sorts of decisions based on that. I'll quickly go this, and I'm going to skip forward to my last slide and take some questions thereof. That's a picture of it landing. That's a picture of it taking off. It was Florida. I was allowed to wear shorts. We had to get special discompens from safety to be able to say, hey, it's really hot. It's Florida. They're like, okay, you can wear shorts. Just don't go to any vegetation. It's part of it. You still got to wear the boots. Maybe the hard hat. We're not sure about the hard hat yet. It's part of that. You see that vertical transition as it descends up to, this case, it's 150 feet. See a little forward movement there as the two servos in the front tip down, and it goes off and starts a 40-mile-an-hour flight time, or flight velocity. I'm going to jump ahead a couple here as part of that. Briefly hit on 3D scenes and web applications thereof. That's really where I'm trying to spend a lot of the focus here going forward is, okay, we have all this data. Let's get it to a usable format for clients and then integrate more fully with, say, ArcGIS Reality that just came out, web app, and then other types of web applications for that development. Jump ahead. And at this time, does anyone have any questions they'd like to ask? Like just one question, just one question. All right, man. Go ahead.
All over the world, knowing, excuse me, thank you. All right, how do you manage getting jobs all over the US, I assume, shipping batteries and stuff? I know that's kind of a hurdle with us. Curious of the census, how the power source is, and is it able to be shipped on a consumer or commercial flight? We have to use UPS.
It does need to be shipped ground. I think there are 458 watt-hour batteries, so there's like a brick that go inside of there. But that's always a difficult one, especially planning ahead of time. So shipping equipment maybe even a week and a half ahead of a project to be able to get to the site. What we found too is, like, with less so with this drone, but more so with other drones, that, okay, well, we'll make investment in batteries here. You make investment in batteries here. We'll ship the airframe back and forth to one another. And that way we can do that. Oh, you need it in 2 days? No problem. Okay, let's ship it on to you that way. Thank you. It's a good question. Yes, sir.
Acronym you were talking about for NERF was?
Let me pull it up on my phone and tell you.
Okay,
I try to memorize it ahead of time and it did not stick. But yeah, I'd be happy to tell you about that.
So the question online is, how many hours for data processing do you allocate for? Ballpark.
It varies wildly, but as an example, let's say we're doing something for photogrammetric data processing with ground control. It might be, depending on the size of the site, a day in the field and a day for the processing. It's also 2 days in the field, 1 day for data processing. So that scalability is there on occasion, but really we're just trying to make sure that there's enough time to accurately give that. I would add to that as a caveat too. My favorite thing is the pivot, as we call it. So I've learned to plan more time on the data processing than I initially would. And it's like, oh yeah, we can do that in 4 hours or what have you. And then they come back, well, what about this product? Well, what about this product? Well, can you clean that surface up? So we've added more time to accommodate for that and anticipate the needs thereof, even when the person we're working with doesn't necessarily know what those needs are at the time. Cool. All right. Any other questions? Cool. Thank you very much.